and welcome to Tech Talks by BIS InfoTech. I am Nikita Kumari, sub-editor at BIS InfoTech. In today's session, we are joined with Mr. Shrikant Acharya, co-founder and CTO of Excelfore Corporation. And as we all know, Excelfore Corporation provides large-scale software-defined vehicles connectivity across global platforms. It's a pleasure to have you here, sir. Thank you so much for joining us.
Thank you as much, Nikita.
Okay.
Pleasure to be here.
Thank you so much, sir. Sir, before we start this interview, I request you to introduce yourself a bit and tell us more about the company.
So, I am, of course, the founder and CTO of Excelfore, and Excelfore has been in the business of connectivity end to end. So, that means cloud into the device and from device into the edge nodes. Now, when I say vehicles, this can be an intelligent building, it can be a
Mm-hmm.
processing what I call process industry application, doesn't matter. Just but we take the automobile as an example, as it's the most complex with diversified interfaces. So so end-to-end connectivity management, which means when the data comes into the car, connectivity is through different interfaces. You have CAN, you have Ethernet. Some things are critical, time critical, so you need to use
Mm-hmm.
different protocols. So we manage all of that. So that's why I said we are unique in the sense that we are able to do an end-to-end connectivity management, or we are modular enough so you can either do just the soda foda, or you can just do in vehicle connectivity. That's
Mm-hmm.
how OEMs use our products today. And we've been in the business for over 20 years.
Okay. Okay, so as how should the industry define trust as vehicles become software centric and increasingly AI driven?
So I think you have to understand things is AI needs data. So
Mm-hmm.
unless you create a what I call an environment where data gets created, there's not much value for bringing AI into the picture. So first of all, so you can see that early devices that you had in your vehicles were CAN and generally not modifiable. Then from so non-modifiable to then it moved on to working towards modifying for bug fixes. So
Mm-hmm.
typically bug fixes were the whole thing would come into the garage shop and get updated. But now the whole idea of trying to do it over the air, and hence the value of over the air update or SOTA FOTA as you can know. Then, as things evolved, you will see that vehicles needed to be managed for their health, performance. Now, early days, it was all mechanical, right? So mechanical parts
Mm-hmm.
fail, okay. You go to the shop, get it replaced. But as the electronification of the vehicle, now I want to make it very distinct between electronification versus electrification. And the content of electronics moved more and more into the vehicle. And then you had this whole growth of cell phones and how the cell phones themselves morphed in functionality with every update and all
Mm-hmm.
that. So the meaningfully, the car started to get matched to what the user experience was for cell phone. So you started to have an environment where, oh, we need to update cars. So now you need to access information from these devices. So as the devices features evolved, they started to give you data. So
Mm-hmm.
now you had ability to collect data from the vehicles, and then you can fix the problems by putting software. So then it was basically and data collection and data correction kind of situation. Now, as we progress further and more functionalities come in and more sensors come in, the ability to comprehend and put everything together in the cloud is going to be difficult because you cannot keep sending instructions back to the vehicle.
Mm-hmm.
The concept came of AI inferencing right in the vehicle. So that way, what happened is you create models in the cloud where they have infinite compute resources. You take the parameters that you're collecting from the vehicle and you can model it. And then you set the model as concise as possible and then drop it into a edge node that it starts working on it. Then what it does is it collects the data. Instead of sending all the data back, it starts to create inferences. So inferences are large, what I call directional uh, positioning as to where the vehicle's health is and all that. So with that started to become, so you had to we had Gen AI in the cloud and agentic AI in the devices. So effectively, it is how the feature evolution of the vehicle has allowed these additional features to be brought in because they are computationally heavy. And so the platform has to involve, clouds have to involve, the ability for devices to send information, take information, and act on it.
Mm. And so, like you said, with the feature evolution, the security is no longer limited to in-vehicle systems. So it now extends to cloud infrastructure as well, like OT pipelines, data flows, and AI models. So from a technology standpoint, which part of this expanded attack surface is still being underestimated?
Everything that is system based
Mhm.
has less problems.
Mhm.
But you make secure devices by putting certificates into those devices. And that's still human. That's where is the biggest, what I call your hack. Because
Mhm.
the guy who is inserting the certificates is the one who can compromise the system. And a lot of compromises that you see really happen at the device programming point. So that to me is highly underestimated. So to me, how do you make this more automated so that less human intervention comes into the play? Will make it more secure. Now, the other thing is, of course, connectivity. The
Mhm.
more connectivity that comes out of the vehicle, the more attack surfaces you create. So you never want to create a link in the vehicle that is more than one, because anything more, the more you create, the more. So that's another point. The other point is uh, continuous authentication. So so typically you authenticate once and you never again go back. So to me, if you want to create more what I call secure, you want to do is session-wise breakdown. So you change the keys often enough that even if the one key is compromised, the next key is not. Even if the key got inserted initially, became compromised. But if you have the process of updating the keys, then the second and the third time it'll become opaque to anybody. So you want to break. So two things. So basically, we talked about making the link secure. We talked about entry points of entering the certificates as being where I think the things have to be
Mhm.
secure. And typically, what you do is you don't broadcast stuff. You have the car come back to the cloud. That way, what happens, the car coming to the cloud is more limited exchange than a cloud trying to figure out where the car is, right? The other thing you have to do is typically you will use CDN. So in order not to tax the link that a central repository has for dispensing your assets like SOTA or FOTA, you deliver them through CDN, right? The CDN is your content delivery network. So you have to make those secure. And the way you make secure is that you create encrypted packets that are delivered into the CDN. But when you bring the packet out of the CDN, you go back to the main server to get the keys. So that way you can unlock the key that. So then you can figure out what keys you want to be delivered. So there are multiple plays where I call hygiene has to be managed.
Mhm.
If your hygiene is managed, then you will have a less problem with hacking.
Okay, and so like the way OTI has evolved from feature updates to a backbone for safety and lifecycle management. So, what are the essential principles to ensure OTI remain secure and resilient?
So two things. First of all, I think just OT alone is no longer the focus.
Mm-hmm.
So now as we evolve,
Mm-hmm.
um, I call it lifecycle management because you will have
Mm-hmm.
diagnostics, you have
Mm-hmm.
remote repair, you
Mm-hmm.
have the data aggregation, you have analytics, and then you have OTA, which is
Mm-hmm.
to fix any debug. So to me, these are all what I call communications that individually have to be secure, right? So to us, it's not OTA alone. So not only OTA has to be secure, your because two things. OTA uses bulk transfer, which is kind of asynchronous, right? You can
Mm-hmm.
run HTTPS. But if you run data that runs on MQTT, which is the short messaging upstream. So, but they are two different connections, yet they are using the same pipe, but they have to use different or like authentication schemes. So they have to have DevSecOps of that basically secure the MQTT channel. You have DevSecOps that secure the HTTPS channel because HTTPS is asynchronous and can be used through bulk, but MQTT, which is what the data is getting, is all synchronous. So you have to secure both channels.
Okay. And as Excelforce SDV Connect framework operate across global platforms, including AWS and Google, so how should SDV platforms be designed to implement zero trust security consistently across clouds platforms?
So the first of all, cloud platforms themselves are quite similar in the
Mm-hmm.
way they are architected. So
Mm-hmm.
you use TLS 1.2
Mm-hmm.
X509. That's an
Mm-hmm.
asymmetric certificate exchange. So to us, the cloud is agnostic to the way you implement security. So
Mm-hmm.
security has to be implemented like you connect to devices, they have to be X509. Every link that connects from the client into the devices has to be X59. But remember, what I call the legacy devices are not secure. So you can only secure to the extent where the domain is connected. So what you do is from the domain to the CAN, what you can do is you can limit what goes on to the bus. So you can shut off all debug ports so that while this update is happening, right? So that only one link is on. So you can use, as I said, some sanitary practices on links that are not fully secured because just the what I call legacy systems were not secure in the beginning. But I mean, I'll tell you, the legacy systems use 40-bit encryption, and 40-bit encryption has been compromised long time ago. So now you can build in, so in a classic CAN, which is only 8 bytes, there's not much you can do. But the CAN FD, which is the flexible, can up to accommodate up to 256 byte, what I call frame sizes. You can actually put a TLS link, TLS encryption in that kind of a situation. But then these are newer devices that are still on CAN, yet they can adopt security, what I call encryption available to them. So I think to me, it's all about the problem in the vehicle is all about legacy devices conflicting with secure
Mm-hmm.
devices. You still have parts of the car that are insecure over parts of the car
Mm-hmm.
that are secure.
Okay, and Mr. Shrikant, you also chair of the eSync Alliance. So you work
Yeah.
closely on standardizing OTA and interoperability. So how do open standards establish baseline security and trust across the SDV ecosystem?
All right. So two things about standards is the extent to which you want to define the boundaries of interaction.
Mm-hmm.
One of the things that eSync Alliance did not want to do is address security as a normative part. And typically, standards have normative and
Mm-hmm.
recommendations. The reason is every OEM has its own way of doing security.
Mm-hmm.
And the problem with all of that is the own way of doing security. So if you mandate one way of doing it, they'll absolutely don't like it. So what we have done is moved the security aspects into the recommendations section. So like for example, BMW will use MACsec, if you're
Mm-hmm.
aware what MACsec is, right? So MACsec is a preferred way that they secure device-to-device interaction. But
Mm-hmm.
some may use TLS, a majority use TLS. Okay, so that's one aspect of link security. But I think one more thing that I have to bring to this point is anonymization. I think this is a big part of the WP 159 and 155, and that is how do you prevent data that is associated with vehicle not to be made public? So you have to make sure that even device identification of the car is no longer win based, right?
Mhm.
So now it's a token based, where once a token is created, it's like your Visa card, right? Once your token is created, it's not associated with the card anymore.
Mhm.
So somebody in the repository knows what this token is associated with. And similarly, even the cards have to be tokenized. So when your token, then the token gets transferred and the anonymous details that are associated with the vehicle no longer get transferred. So you have to address the GDPR regulations as well. So then that I would say, so when we talk about all of this
Mhm.
is all outside the framework because the envelope can manage anything you want. So we don't try to enforce where the government regulations come in, where individual preferences on security profiles come in, because standardization is not going to create adoption when you have what I call conflicts. So what we do is we work with standard bodies. We work with SOFISIG, we work with Autoware Foundation, we work with ASM and figure out how this is being managed in different standard. And then we make sure that we work in a coherent way between each other.
Okay, and like as AI increasingly influence vehicle behavior, security concerns shift from static software to data integrity and model updates. So, how does this change the future vehicle engineering?
So two things are, so first of all, let me say
Mhm.
this, it does not substantially change. It's just that
Mhm.
the AI is a model. It acts on some information, right?
Mhm. Mhm.
But in order to transfer, you still it's a data packet. It's a container that gets
Mhm.
transferred. So I don't think the distinction is much going to be different because in the end, what you're going to deliver from the cloud server into the car is some packet, but
Mhm.
the packet integrity has to be maintained, which means you have to make sure that there is a secure hash encryption that guarantees the integrity of the data. Then you basically attach different certificates of origin so that we can track it down where the problem is, because problems will appear. But you have
Mhm.
to very quickly figure out who is the origin from where the software originated, because OTA systems will not verify software, right? All they can
Mhm.
verify is that what you inserted is what is
Mhm.
getting delivered. That's what is being guaranteed. So beyond that, the OTA is not going to decide as to whether there is a malware or not. That capacity is the at the origin,
Mhm.
right? So
Mhm.
somebody. That's why I said compromise happens wherever humans are handling stuff,
Okay.
right? So it's at
Mhm.
both ends. It's not in between because they're fairly mechanized and automated.
Mhm. And Excelfore is extending SDV Connect into autonomous systems of highway machinery and smart battery platforms. So can a unified security framework shape these domain, or do trust models need to evolve based on on the application?
I would say trust models is all about connection management, right?
Mm-hmm.
So whether it's a construction machinery, it's a question of, hey, construction machinery is so big, it may have multiple camera inputs, multiple sensors. So
Mm-hmm.
those have to be made secure. Now they could
Mm-hmm.
be wireless because they are so big that the
Mm-hmm.
wiring would be what I call rather unwieldy in connecting the. So they'll all be wireless. So now you have to secure them wirelessly, right? So you will have different what I call manifestations of how you'll secure these endpoints.
Okay, and the way software-defined mobility relies on collaboration between cloud platforms, semiconductor platforms, and standard bodies. So, in such a distributed ecosystem, how should trust responsibility be structured to avoid security blind spots?
Yeah, I think let's split this conversation. One is
Hmm.
you have if you start using phones, for example, as
Hmm.
your modem, that's a secure platform because
Hmm.
we're not in control of it.
Hmm.
If you're sitting in a TCU in a vehicle, you can put a firewall. The firewall
Hmm.
is not being tampered with, but phone
Hmm.
is very unsecure. But yet people want to use phones, right? Because it's cheap, it's handheld, and everybody has it. So this is the dichotomy. I mean, you have you have patently unsecure environments, but they are being used because they are useful for what I call quick interaction and closure. So I think you have to figure out how these points become secure in a way. So you have to make sure that there's nothing that gets unraveled,
Mm-hmm.
and all you do is managing connections, and it should be very fixed. You cannot have one to many, it has to be one to one. So you have to enforce certain what I call authentication of the links, so that the phone, even though is a preferred medium, which is highly insecure, is tried to being secured. And so you have to keep, like in this case, it's more important to change the tokens
Mm-hmm.
often,
Mm-hmm.
because somebody is going to keep spying and trying to hack into it. So if you don't change it enough, then at some point you will get hacked. So coming back to how you manage systems. So managed systems are, if you're static and firewalled, they are more secure. But if you move like these mobile devices, then you have a problem, because two things are important in mobile devices. If you can create a physical isolation, that is
Mm-hmm.
memory and uh, OS isolation, and they are physically separate from the rest, that's one way to secure it. Because if OS is, say, for example, Android sits on Linux. I mean, I don't think that's a secure platform.
Mm-hmm.
But
Okay.
if you create a real-time OS,
Mm-hmm.
which is secure,
Mm-hmm.
such as Green Hills or even QNX
Mm-hmm.
microkernels, but that creates separation, physical
Mm-hmm.
separation of the applications, then they can be made secure. But you cannot inherently Linux is not a what I call classically secure platform.
Okay, and before we wrap up this session, my last question is to you that for technology providers building the next generation SDV platforms, what foundational security capability should be prioritized today to remain resilient in an AI-driven and software-defined mobility future?
So you have to first understand what are the components of an SDV. So the
Mm-hmm.
components, there are several. If you look at a
Mm-hmm.
SDV view, you have the cloud hyperscalers, then you have the OTA, then you have
Mm-hmm.
data aggregation, you have the
Mm-hmm.
analytics, you
Mm-hmm.
have what I call this uh, executive that goes and manages the various functional elements like ADAS, your infotainment. And they are all sitting in a massive compute environment. It's a single compute environment. So now what you want to do is this OS or this particular executive that's actually separating a big compute block into sectional blocks. So now that becomes a very important piece of software that could actually, if not made secure, is going to be a problem for it. So
Mm-hmm.
now, when you talk about big compute environments, your every aspect that you put in that is managing any piece of software. Now, for example, if you have six components, each one is managing a critical aspect of the function of the vehicle.
Mm-hmm.
To us, you have to secure those blocks, and you have to secure the executive that is actually
So we have
delivering.
to secure each component particularly for that
Yes.
purpose.
So you say command is not secure because you're putting them into the physically separate, isolated boxes
Mm-hmm.
inside and then of course this executive itself that's
Mm-hmm.
managing all of this. So how do you update this secure block? So initially it'll be fine, but how do you manage that secure? So I think to me, um, when you create these virtualized components, the virtualization mechanism itself has to secure, like a hypervisor.
Mm-hmm.
So
Okay, sir.
you'll create many more. I mean, that's one more reason you want standards for SDV,
Mm-hmm.
because if it's a crowdsourced aspect of development, there's a much quicker way to solve the problem. Which is I mean, you look at how cloud today gets solved. I mean, if there is a breach, it comes. So some companies do get affected, but before others get affected, they get published. There is a quick, what I call fix. Everybody fixes it. So every rest of the systems become very intelligent to fix the problem. So the only thing with SDV is if you have to make it secure, they have to be as openly defined as possible at every interface joint. If you don't do in every interface that is working is not
Mhm.
secure in its own way, then you will have a problem.
Okay, thank you so much, sir, for taking the time to speak with us. And it was really insightful to understand how trust and security shaping the future of software-defined mobility. Thanks for taking the time to speak with us. Thanks a lot.